Okay, and in the previous sections, we got the formulas how to get the area of the triangle, and how can we get the law of size and for the formula. So now how to prove that? We use the formulas for the area of the triangles, and we got the formula. And next step, we divide this two sides for a half and six. So we got b side a equal a side b, and after all we got this formula a divide side A equal B divide side B.
Right, let's get into the first example. Angle A equals 60 degree, angle B equals 75 degree, side C equals 10. Now we can draw the triangle first, ABC. Now plug those numbers in this formula. A over sin A equals B over sin B equals C over sin C. Now, for those information we already know, we can get angle C by knowing the triangle is 180 degree minus those angle A and angle B to get angle C. Now we get the side C and the angle C, so we can just use this information to get rest of the angle and the side. So plugs C, angle C and C into the formula, and we can get sine. So we can get B. We already know angle B is 75 degrees, and so we can plug this number in. B equals 10 over sine 45 times sine 75, and we can get the side B. Also to the A equals 10 over sine 45 times sine 60, and we can get the side A.
Okay, then let's see the example question 2. The A equals to 40 degrees, A equals to 7, and C equals to 10. So first we got the angle A equals to 40 degrees and the C equals to 10. But when we are drawing the A, we can see there are two situations. They both satisfy our things. So let's just talk about them separately. The first situation, we make it like this. And so we can simply use the sine A over A equals to sine C over C. We can simply got sine C equals to sine A times C divided over A. So we can got C equals to sine inverse of the C over A times sine A, which is 66.674 degrees. And then we can just solve the angle B, which is 73.926 degrees, and then we can just simply solve B by use B, which is equals to A over sine A times sine B, which is 7 over sine 40 degrees times sine 73.926 degrees, which is 10.464. Then let's talk about the second situation. Then we still got the same first step, which is angle C equals to sine inverse of the 10 over 7 times sine 40 degrees. But in the unit circle, we can see in the first and second quadrant, we can got there are two angles with the same sign, and actually we are talking about the reference angles. So we can got the other angle between 0 to 360 that have the same sign, which is 113.326 degrees. So, and we can just solve B, then use the same method, which is 26.674 degrees, and B equals to 4.888. Those are just the same thing. So we can see as soon as we have one angle and its opposite side and another angle or another side, we can use the law of sines to solve the triangle. And for the ASA and AAS, we can just use that, we can just solve that there is only one situations. But for SSA, there are two situations. So as here, we just need to use our mind to see beside that angle there is another angle between 0 to 180 degrees that have the same sign as the reference angle. Actually, in my mind, there is a very useful way to solve the SSC situation, and we won't miss one solution. Is that let's look back to the previous question. We got angle equals to 40 degrees and c equals to 10, or they're all the same. And instead of drawing A, we draw height, and we draw isosceles triangle, which makes the two sides equals to 7. And we will just got this will just combine the two solutions into one triangle, and we can simply got that angle is 66.674 degrees, so the same as the other base angle. So we can use this to solve for all the angles, and they're all the same. And we can just use the height and the 7 to solve for the two small sides in the bottom, and that's the way I usually use to solve for the SSA situations. It's pretty easy. We change one normal triangle solution into a right triangle, and that's very easy to solve, and we can hardly miss the other solution. And that's all we want to talk about this law of sine. And if you have any questions, just ask Mrs. Clausen or ask us. We can solve that. And thank you for watching.